Going to discuss about the boundary condition of electric field. Okay, here we are going to consider two different cases. One is the electric field intensity as well as electric flux density. Okay, so the case one we are considering for one bell box. It's the A, B, C, D. It's have the one bell box. Okay, you can consider the two different medium. No, so the length, that is the del Y, and breadth is del X. We consider like that. So you are segregated in the two medium. The medium one which have the electric field intensity of E1 and permittivity, that is the epsilon 1, and the tangential component of electric field intensity of the medium 1. So we are notated all the notation in the medium 1. Similarly, the medium 2 which have the electric flux density in the medium 2 E2. Similarly, the tangential component of electric field intensity, that is the medium 2. Then relative permittivity. So we are segregated all. Then the normal component, this is the tangential component of electric field intensity, that is the ET1. That is the another one electric field intensity, that is the normal component of electric field intensity dN1 and dN2. So actually the medium 1 and medium 2 we are segregated equally. So the tangential component of electric field intensity of the medium 1 it should be equal to medium 2. Okay, the electric field intensity of the medium 1 it should be equal to medium 2. So we all know the relationship that the conservative vector field, the E into dl equal to 0. We all know. So the potential it should be equal to the line integral of electric field intensity, it should be equal to 0. That is the conservative vector field. So because this also closed loop, so we consider the expression. From that E into dl it should be equal to the sum of the tangential component of electric field intensity as well as normal component of the electric field intensity in the medium 1, that is the ET1 into del Y, because that is the length. En1 in del X. Here the En1, the corresponding length, that is the del X. That is the medium 1. It should be subtracted with the medium 2. Okay. So the minus Et2 del Y. Similarly Et2 del Y. Then En2 del X. Okay. The tangential component of electric field intensity of the medium 1, it should be equal to medium 2. Okay. So the sum of electric field intensity of the medium 1 and 2 equal to 0. Okay, that is the both are equal and the opposite, both the medium. So here we consider for the electric field intensity of the tangential component of electric field intensity of the medium 1 equal to medium 2, because here del X is 0. If the del X is 0, here the En1 it is getting 0. Similarly En2 also getting 0. So the Et1 into del Y minus Et2 into del Y. So while you are equal in the both the side, so the minus it is getting plus. That is why Et1 del Y it should be equal to Et2 del Y. So the del Y is the commonly available both LSI side and RSI side. You can cancel it. So you are proved the tangential component of electric field intensity of the medium 1 it should be equal to the tangential component of electric field intensity in the medium 2. That is the case 1. Et1 it should be equal to Et2. Similarly, we need to prove the electric flux density of the medium 1 as well as medium 2. Here we are consider the rectangular box. Here we are consider one bell box, that is the cylindrical box like that. So here also you segregated two medium. The medium 1 it's have the electric flux density of the that is the dN1. Similarly, in the medium 2 it's have dN2. Similarly, the medium 1 it's have the permittivity epsilon 1 and epsilon 2. Here also here the del X, that is the total length. So here we are consider the total surface, that is the ds. Here also the dN1, that is the line integral of electric flux density. Here we are consider the bell box. So here the surface integral it will come. There it will applicable for line integral. Here it is applicable for surface integral. Both length and breadth we need to consider. So the surface integral of normal component of the electric flux density of the medium 1 and medium 2 is equal to 0. Okay. So the dN1 it should be equal to dN2. So in terms of volume charge density, so we are expressing like that. In terms of dN1 minus dN2, that is the total volume. If the total volume if you are consider, we need to add one thing, that is the, if you are consider the dV it should be